Bench testing a 1958 Cadillac Headlight Switch with the fog light option. Serial number 01072022. Offered by TT Parts Rebuilding. Run-up test. Test number 1, tail and parking light operation. Test number 2, tail and headlight operation. Test number 3, dash light operation, low to high. Test number 4, tail fog light operation. Test number 5, headlight load test. Test number 6, switch insulated from ground. And test number 7, circuit breaker operation. Using a fully charged battery, indicating here 13.51 volts, the first position test will be tail and parking light operation. First position, indication of tail and parking light. Test operation number 2, tail and headlight. We see the front parking lights off and the headlights are on. Tail lights remain on. Going back to parking, we see parking, tail, and off. Test number 3, dash light operation, low to high. First position, parking and tail lights. Rotating the rheostat, we see an indication of a dash light. And rotating, and slightly brighter to full on. Again, counterclockwise. Dimming of the bulb, and off. Rotating again, on, brighter, full on, and off. Next test will be our tail and fog light operation, which is test number 4. First position, you have an indication of parking and tail. Using the control switch that's just behind the pull rod, we're going to rotate the switch to the fog light position, and we have an indication of fog lights, but we see the parking lights are off. The early model Cadillacs were using generators, and they couldn't really hold up the demand for parking in the front and also the fog lights. So with this switch combination, it'll shuttle between parking and fog. Going to the headlight position, we see that that option is no longer available. Again, limited source from the generator for amperage limited the operation of both the fog and the headlight. So that feature is not available in the headlight position. Only in the parking, we have an option to do parking and fog. Taillights remain on and off. Test number 5 will be the headlight load test. Going to the headlight position, number 2. We'll remove this test lead for this indicator and connect up a halogen bulb. Halogen bulb has quite a demand on the circuit. This will test the continuity of the contacts in the switch, and also we'll do the integrity of the switch by wiggling the pull rod to see if there's any fluctuation in the current going to the bulb. Now install the halogen bulb in the circuit. We'll turn on the parking lights and then go to headlights, and we wiggle the switch pull rod and we see there's no dimming of the bulb. Indicates a tight switch in the contact area, and off. Test number 6, switch insulated from ground. Using a 12 volt test light, we see we have continuity to the switch chassis to the 12 volt source. Now we're going to switch it back, connect the ground lead to the power source. Do the test again. We see we have ground to the chassis, no short the ground terminal 1, terminal 2, terminal 3, terminal 4, terminal 5, and at the breaker area. But to the chassis we have ground. So if there was a short from one of these terminals to ground, it would give a situation where you could have blown fuses and tripped circuit breakers. We see that the switch is insulated from ground. Test number 7, circuit breaker operation test. We've powered up the battery terminal and we see that we have continuity through the contacts. We're going to break the contacts. Indicates the light turns off. Release the bimetallic spring and the circuit is complete again. Test number 6, switch insulated from ground. Using a 12 volt test light, checking for power we see that the light Test number 6, switch insulated from ground. Using a 12 volt test light, we see we have continuity to the switch chassis to the 12 volt source. Now we're going to switch it back, connect the ground lead to the power source. Do the test again. We see we have ground to the chassis. No short the ground terminal 1, terminal 2, terminal 3, terminal 4, terminal 5, and at the breaker area. But to the chassis we have ground. So if there was a short from one of these terminals to ground, it would give a situation where you could have blown fuses and tripped circuit breakers. We see that the switch is insulated from ground. The next test we'll be conducting is a circuit breaker test. I'm going to power up the circuit breaker terminal. I'm going to ground the switch and see there's continuity at the breaker. I'm going to break the circuit as an indication of the power of the. Do a circuit break. You see that the break of the circuit, holding down the bimetallic spring. Situation where there's a short in a vehicle, and anywhere in this switch circuit, this bimetallic spring would trip. Test number 7, the circuit breaker test. Check test number 7, the circuit breaker continuity check. We powered up the terminal, the battery terminal. We're going to ground. We've powered up the battery terminal. Connect the other test lead to the back of the bimetallic spring. Break the circuit. And we have a light. Test number 7, we're going to check the contact area between the power battery terminal. Test number 7, circuit breaker operation test. We've powered up the battery terminal and we see that we have continuity through the contacts. We're going to break the contacts. Indicates the light turns off. Release the bimetallic spring and the circuit is complete again.